Hello everyone, welcome to this course on OCI Database Service. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. In this course, we will look into the various options available with the OCI Database Service. We'll dive deeper into their features and then we'll go over a quick demo and launch a one node database system. So let's get started. OCI Database Service offers mission-critical enterprise-grade cloud database service with comprehensive offerings to cover all enterprise database needs. So we have a virtual machine option available. We have a bare metal option available. We have real application clusters supported in OCI. And finally, we also have Exadata available in the cloud. Now, these three options are only available in the three options: bare metal, real application clusters, and Exadata are the options which are only available with Oracle Cloud Infrastructure. They are not available with any of the other cloud providers out there. So it's a very comprehensive range of offerings available with the OCI Database Service. Not only that, we also offer complete lifecycle automation, including provisioning, patching, backing up the databases, and restoring them. We have several options available for high availability and scalability. Like I said, we have real application clusters for HA. We also have support for DataGuard for HA and DR. And then we also support dynamic CPU and storage scaling. We have various capabilities built in for the security, and the way to think about security is on two dimensions. First, we leverage a lot of security capabilities built in the platform itself. So these are things like identity access management, where you can decide who has access to the database and what level of access do they have. You can go very granular. We have virtual cloud networks. All these databases are running behind a virtual cloud network. So you can do things like routing and have your firewalls, your security list set up. And then we also have things like audit logs. You can see who is making the API calls. So the service leverages a lot of infrastructure security capabilities. And then we also have the various database security capabilities. So things like transparent data encryption, things like, the fact that our storage has server-side encryption. You can bring in your own keys, etc. Right? So security, you should think on those two dimensions. And then we have the OCI platform integration, so you can do things like tagging, etc. And then finally, customers can also bring their own licenses. So if they have licenses existing in their on-prem environment, again, this is the only cloud where they can bring in the Oracle database licenses is Oracle Cloud Infrastructure. So they can leverage the existing licenses in OCI Database Service. So with that introduction, let's look at the different flavors of the service, starting with the virtual machine DB systems. So today we support two different flavors: our Gen 1 X5 and our Gen 2 X7 offerings in the virtual machine or the VM DB systems. And you can see the characteristics there. In the second generation, we go from 1 to 24 CPUs. We have the memory listed here. You can see the storage, the network, etc. And these charts here show you all the the various scale options you can use with our current gen VMDB systems. Now, when you're spinning up a virtual machine DB systems, you can spin up a single instance VMDB system, or you can also do a two-node rack. Today we are limited to a two-node rack real application cluster, and that's a fantastic solution for high availability. So highly recommend to look into that if you are looking for any kind of HA construct. Now, several things to keep in mind. The VMDB systems leverages block storage, so there is no local storage for VMDB. Keep that in mind, and the fact that we replicate the block storage drives is actually useful. We'll talk about this in case of the VMDB systems. The second gen shapes are more performant than the first gen shapes at the same price. So highly recommend to use the second gen shapes. We use things like SRIOV to speed up the network. You can see the network goes from around a Gbps to to 25 Gbps. Same thing with memory, same thing with the CPU cores, and the Gen 2 shapes have more IOPS, around 100% more IOPS than the Gen 1 shapes. So the idea is always you should be on Gen 2. With VMDB you can go with 1 node or 2 node rack. VMDB always uses block storage, there is no local storage. Gen 2 is more performant than Gen 1 at the same price, and then VMDB is really ideal if you have databases where you go all the way to 40 terabyte, which is actually a lot, but if you have databases going all the way from 256 gig to 40 terabyte, the sweet spot is the virtual machine, the VMDB systems. As we talked about the storage architecture, ASM is a volume manager and a file system for Oracle database files that support single instance DB and real application cluster rack configuration. So you can see ASM being mentioned here. Let's just talk a little bit about how the ASM architecture is built using VMDB systems. So for the VMDB systems, ASM relies on block storage for mirroring data. Remember we talked about the fact that VMDB systems only have block storage, and ASM has a couple of redundancy models. It's including normal and high redundancy. So normal means it's a two-way mirroring, high means it's a three-way mirroring. So ASM relies on block storage for mirroring data. It relies on the external redundancy, relying on the triple mirroring of the block storage. So this we do anyways, the triple mirroring, and ASM actually leverages that. Different block storage volumes are used for data and recovery, and there are different percentages for those, and we monitor the disks for hard and soft failures, and with these capabilities we ensure highest levels of availability and performance at all times for the VMDB systems. Now we looked into the VMDB systems, the characteristics, the Gen 2, the size of the database you can support, and we looked at the automatic storage management, ASM, how it's done for VMDB systems. Let's change gear and look at the bare metal DB systems. Now for bare metal DB systems, as the name specifies, it relies on bare metal servers running Oracle Linux. So as you can see here, the same architecture valid for both X5, the previous gen, and X7, the current gen. And with the current gen you can go to 52 cores, 768 gig of RAM, and 51 terabyte of storage, and the price is based on CPU, OCPU. So it's always a good idea to go with the current gen model. Now for one node database, so currently the bare metal DB system is limited to a single node, one node DB system. So you get a single bare metal server, you get a locally attached storage, either 28 terabyte for Gen 1 or 51 terabyte for Gen 2, and remember this is raw storage. The one good thing about the bare metal DB system is there is some kind of licensing elasticity built in. So you can start with 2 cores and you can scale up or down your OCPUs based on your requirements, and then as you scale up or down, you only pay for those cores as far as database licensing is concerned. For the bare metal you pay for the whole 52 cores, let's say if you go with the 52 core Gen 1 bare metal server, but for licensing the Oracle database you don't necessarily have to pay for all 52 cores. You can go start with 2 cores and you can scale up and down every hour, and you can make it very elastic. So you are only paying for licenses depending on the number of cores you require. You can also have options like data guard available within the AD and across ADs in a region. So remember it's limited to a region. The one you can do which comes with the service, and you can always set up your own data guard between regions. If single node fails, we launch another system. You can launch another system and restore the database from the current backups, because there's a capability to do backups for the bare metal DB systems as well. These are the configurations like we saw for the VMDB system. This is our current gen. So you can see 52 cores, 768 gig of RAM, 51 terabyte of memory. It's a single instance, of course, both of them, and you can scale the capacity on demand to 52 cores for the DB. And then we also have 25 Gbps networking. So bare metal database system is really ideal for situations where you need mission critical databases, and you need that kind of, the number of cores, the storage, or the network throughput of 25 Gbps. Then you should go for the bare metal DB systems. Now the architecture looks a little bit different for ASM for bare metal DB systems compared to the virtual machine DB systems. So first thing you notice here is it leverages local storage, because as you recall, the bare metal DB system comes with local storage, right? So for the two-way mirroring and the three-way mirroring, the service leverages the local NVMe disks. Like the virtual machine DB systems, disks are partitioned, one for data and one for recovery. We monitor the disk for hard and soft failures, and proactively offline disks that fail are predicted to fail or are performing poorly, and we perform corrective actions if possible. On disk failure, the DB systems automatically creates an internal ticket and notifies internal team to contact the customer. So I have this running in my account, and once in a while I would get an email saying something is going wrong with your DB system, right? And this is what the corrective actions you have to perform. So don't think that because it's a bare metal DB systems, if you are running your own database on a bare metal DB systems, you don't get these characteristics, you don't have these features, because you are responsible for managing your mirroring of the disk, and you are responsible for managing if something goes wrong with those disks. But because this is a service, BMDB systems, we do these, we perform these actions, and we make sure that if there is something which is going wrong with your disks, we take the corrective action and we notify you. So as a result, these actions ensure a high level of availability and performance at all times. Now Exadata is DB systems is our gold standard for the database, right? It comes with all the advanced options, things like scale out compute, scale out storage, InfiniBand, PCI, flash, you name it, right? This is our highest level of fastest, highest performing database option available in the cloud. Now remember, as I said in the beginning, the bare metal option and the Exadata options are only available with Oracle Cloud Infrastructure. They are not available with any other cloud provider other than Oracle Cloud Infrastructure. So with Exadata DB systems, Oracle manages the Exadata infrastructure, including servers, storage, network, firmware, hypervisor, all of it end to end. You can specify 0 cores when you launch Exadata. This provisions and immediately stops the system. You are built for the Exadata infrastructure for the first month, and then by the hour after that. So you don't have to pay for the whole month, you just pay by hour after the first month. Each OCPU you add to the system is billed by the hour from time you add it. Scaling from a quarter rack to a half rack, or from a half rack to a full rack, requires that the data associated with the database deployment is backed up and restored on a different Exadata DB system. And right here you can see for a quarter rack, half rack, full rack, the configuration. So this is our current gen. You can see the configuration here, you can see the configuration here, and right here, and you can see the things like the number of compute nodes, the 2 nodes, 4 nodes, 8 nodes, going from quarter to full rack. You can see things like total maximum number of enabled CPU cores, 92 cores going all the way to 368 cores, and so on and so forth, right? So this gives you a lot of details on the different configurations we support in the previous generation as well as the current gen Exadata DB systems. We are going through the ASM architecture for each of these flavors, each of these options. So Exadata DB system, Exadata has its own local storage. Now of course this is also based on NVMe SSDs, but the way it functions is a little bit different than the VMDB and the bare metal DB systems. Now there are two options. You can provision the backups on Exadata. If you do that, 40% of the available storage is allocated to data and 60% is allocated to recovery disk groups. If backups are not provisioned on Exadata storage, 80% of the available storage can be allocated to data and 20% are allocated to the recovery disk group. So again, you have different options, you can go with either of them. Just keep in mind that after the storage is configured, the only way to adjust the allocation without reconfiguring the whole environment is to submit a service request to Oracle. So now let's summarize all these different options, because there are different things which are available with these different options. So it's important to keep in mind as to what is available and what are the characteristics. So let's first look at scaling. So in case of a virtual machine DB system, you can scale storage. You can increase the storage, but you cannot scale CPU. Number of CPU cores on a VMDB cannot be changed after you provisioned it. Now on a bare metal DB system, you can scale CPU. We talked about this. You can go from a 2 core all the way to 52 core for a current gen VMDB system, and you can scale down as well. You can scale up and scale down, but the amount of available storage cannot be changed, because you get a pre-configured local storage. Either it's 28.8 terabyte or it's 51.2 terabytes, right? And you have to stay with those options. You cannot scale your storage. Now in case of Exadata, CPU can be scaled within a quarter, half and a full rack storage, full rack option. Storage cannot be scaled. Currently this is the case, but it's going to change very soon, where you can scale your storage as well. So that's all about scaling. Multiple homes or databases. In case of a VMDB, it's not supported, so you are limited to just a single DB and home. In case of bare metal, yes, you can have multiple homes and databases. Just keep in mind it has to be one edition, but different versions are possible. In case of Exadata, of course, you can have multiple homes and databases. As far as storage is concerned, VMDB system, we talked about this, relies on block storage. There is no local storage here. In case of bare metal DB system, it relies on local NVMe disks. There is no block storage. And in case of Exadata, it has its own local spinning disks and NVMe flash cards. So it has its own custom storage solution. As far as HA is concerned, the real application clusters are available with the VMDB system. Today you can create a 2-node rack. You cannot do like a 6-node or 16-node rack, but you can create a 2-node rack. It's available. In case of bare metal DB system, these are single instance database solutions, so you cannot create a rack. It's not available. And in case of Exadata, of course, you can create a rack solution. And then finally, for DataGuard, virtual machine doesn't support DataGuard today. So if you're thinking of doing HA or DR, that's not available. For DR, bare metal does support DataGuard within an AD and across ADs within a region. It's available out of the box. And then for Exadata, DataGuard is available, but you have to manually configure DataGuard on Exadata DB systems using native Oracle database utilities and commands. DBCLI, for example, is not available on Exadata DB systems, right? And you can read more about them in the documentation. So scaling, CPU or storage, multiple databases, storage, high availability, and disaster recovery. So these are the options which are available if you choose a virtual machine DB system, a bare metal DB system, and an Exadata DB system. Now, having looked into that, these are the different options which are supported. The different database editions and versions which are supported. You can read more on our docs. And then these are the database editions and options available for each of those editions. Now, how so we looked into the basics of the DB systems, the virtual machine DB systems, the bare metal DB systems, and Exadata DB systems, and we had a nice comparison of which feature is available with which option. Now let's look at some of the characteristics of the service, which is consistent across all the options. Things might be a little bit different with Exadata, so you should read more on that in our documentation, but pretty much, you know, most of these things are consistent across the options. So first thing is, how can you manage the DB systems? You can launch a DB system, you can start, stop, reboot DB systems. Just keep in mind that the billing continues in a stop state for the bare metal DB systems, but not for the virtual machine DB system. It makes sense because the bare metal DB systems uses the NVMe drives, and like the bare metal compute instance, you have to pay for them, right, even if they are in a stopped state. You can scale CPU cores for the bare metal DB system. You can scale up storage for the virtual machine DB systems. We looked into that in the previous slide. And you can terminate a DB system, and you can delete any database running on it, right? Pretty straightforward. You can also patch DB systems. So there is automatic patch discovery and pre-flight check and tests available. You can also do on-demand patching. The patches are available on for example on the console, and you can go and you can apply those patches. For Exadata and rack shapes, patches are rolling. For single node systems, if Active Data Guard is configured, this can be leveraged by the patch service. So you want your database to be up and running when you're doing the patch. You have a bunch of those options available. Patching is a two-step process. First, you patch the DB systems. You sort of think about this as the actual hardware on which your database is running. So you do that, and then you apply the patch for the database. DB systems, as you can imagine, needs to be patched first before the database is patched. And right here you can see a couple of screenshots on how the patches are available. Here you can pre-check, and then you can apply the patch, and first the patch will apply to the DB system, and then the patch will apply to the database. And you can see here there's a DB system patch, and then there's a database patch. And finally, because the service is integrated and leverages other OCI services, you can decide using identity and access management service who has the granular permissions and control, and you can control who can list patches, who can apply patches, etc. Backup and restore. So we also have manage backup and restore features available for VM and bare metal DB systems. Exadata backup process is a little bit different, requires creating a backup config file. Now backups can be stored in local storage, which is not really recommended. The recommendation is to store the backups in object storage, which is the sweet spot for storing small or large backups, and it provides you things like high durability. DB systems in private subnets can leverage Service Gateway. We have looked into this in the VCN course, where you have this capability called Service Gateway, which can take your backups from private subnets all the way to object storage. Object storage, remember, it has a public endpoint, but in this case the traffic doesn't traverse the internet, it traverses Oracle private network, and you can go and you can back up to object storage. The advantage here is the subnet can be private, and your database doesn't need a public IP address to enable backups. There are a couple of options available for backup. There is automatic backups. This is incremental in nature. It runs once per day, repeats the cycle every week, and the backups are retained for 30 days, and after that it gets deleted. You can always do on-demand standalone full backups as well. You can restore a DB, and when you want to restore it, these are the options you get. You can restore to the latest, you can restore to a particular timestamp, and you can also restore to a system change number. Let's talk a little bit more about automatic backups. By default, automatic backups are written to the Oracle owned object storage bucket. Customers are not able to view or edit or change the object storage backups, the one we do automatically. Default policy cannot be changed at this time. The backup window is defined by Oracle. Now this is a very new feature, just got launched a few days back. Automatic backups enabled for the first time after 20th November 2018 on any database will run between midnight and 6 a.m. in the time zone of the DB system's region. Earlier it always used to be midnight and 6 a.m. UTC. So for some customers it was disruptive because this fell in their normal business hours. So now this is changed. If you have databases which are still following the old backup window, you can contact Oracle support and you can change it. But going forward, this is always between midnight and 6 a.m. in your own time zone, the time zone of your region. Backup jobs are designed to be automatically retried. I get emails like these when some backup fails in my own account. I get an email that we retry and your backup succeeded, and then Oracle automatically gets notified if a backup job is stuck. This is the email I was talking about, and all backups to cloud object storage are encrypted because the object storage service has encryption turned on by default. And then you can go here and read a little bit more on if there is backup which is failing, how you can troubleshoot and what kind of options do you get from Oracle. Let's talk a little bit about high availability and scalability. And remember, this is a level 100 course. We also have a level 200 course where we go and dive deeper into things like HA and scalability. So today, this service is running on OCI, so we leverage the 3 availability domains architecture. We have fully redundant non-blocking fabric. As we saw, ASM relies on a 2-way or a 3-way mirroring. And then for Exadata, of course, this is the gold standard. So we have things like InfiniBand, redundant in InfiniBand for cluster networking. Now, there are a couple of options to enable HA. As we saw in the previous slides, we can go with the database rack option, which is available with the VMDB systems, right? Or we can go with automated data guard within and across ADs, which is available with the bare metal DB system. So you can use these options. We can also do dynamic CPU and storage scaling, dynamic CPU with bare metal DB systems, and dynamic storage scaling with the virtual machine DB systems. So let's look into data guard. Data guard is supported on bare metal DB systems only today. It's limited to one standby database per primary database on OCI, and standby database can be used for queries, reports, tests, backup. Now there are 2 modes which are available when you talk about data guard. One is called switchover, which is a planned role reversal, and in this case there is no need to do any instantiation of the database, and this is used for data center moves, database upgrade, tech refresh, etc. And you can manually invoke via enterprise manager, or you have DGMGRL service, data guard manager service, or SQL plus. There is also a mode which is called failover. This is unplanned failure of primary, and you have to reinstate the original primary. You can like switchover, you can manually invoke via enterprise manager, data guard manager, SQL plus, and you can also do automated failover using an option called fast start failover, FSFO. And if you go on our documentation, you can read a lot more on how to set up FSFO on OCI. And we have, again, as I said, we have a level 200 course where we dive deeper into that. Now, what is our best practices recommendation? So first recommendation is to run the primary, secondary, the standby, and the observer in different ADs, because you don't want all of them to run in the same AD, and so if the primary goes down, your standby goes down as well. Observer determines whether or not to fail over to a specific target standby database, right? So that's the role of the observer. And you can read about all this, how to set it up in our documentation. Now, when the automatic database fails over, the cases where it will fail over would be things like database is down, there is a designated health check condition, or there is a request coming from an application. The data guard today is supported with maximum availability, maximum performance, and maximum protection options, and you can choose one of these options. Just keep in mind that when you go through the console, you can only set the default mode is set to maximum performance. So you can only choose this option when you configure DataGuard using the OCI console. I believe you can change that when you use the CLI, but with the console, the option which you are limited to, the default option is maximum performance. We talked a little bit about the security features because the system OCI database systems run on on OCI. They leverage the platform capabilities. So we leverage all the network security and access control capabilities, right? The VCNs, route table, firewalls, etc., gateways, etc., right? We leverage the connectivity option, the DRGs, the VPN, fast connect. We leverage all the identity access management capabilities. So things like compartment, security policies, authentication, authorization, etc., right? Then the one I didn't really talk about at the beginning is if you're running on a bare metal instance, the two big advantages of bare metal are performance and isolation. So you get that with for the bare metal DB systems. And then from right here are some of the things you get with the database themselves, right? So you have transparent data encryption, TD. You have RMAN encrypted backups, things like TLS support, right? Logging, etc., right? So there are a lot of bunch of security capabilities, some coming from the platform side, the ones here, and some coming from the database security capabilities itself. Now with that, let me just quickly spin up a virtual machine database system. I'm not going to do a rack demo here, but let me just do a VMDB instantiation and see the experience you get with the OCI console. So I'll switch over to my OCI console. We have been using this compartment called training for all our other courses. So as you can see here, today I don't have a DB system. There is no backups here. And so first thing I'm going to do is I'm going to create a DB system. So it's asking for a name. So I would say this is my DB system 1. And I need to pick up an availability domain. So I'll pick 81. That's fine. And then it gives me an option whether I'm going to go for virtual machine, bare metal, Exadata. Remember, those are the three flavors we talked about. So if I choose VM, I have these different options available, right? If I go with bare metal, similarly, I have choice of Gen 2, 52 cores, or Gen 1, 36 cores. If I go with Exadata, I can choose between a quarter rack, half rack, and a full rack, right? And this is my Gen 1, this is my Gen 2. Very straightforward, simple, same APIs. You can see the only cloud where you get these options, either you are calling a VMDB, bare metal DB, or Exadata, right? So it's very straightforward, very simple for customers, same API. So I'll pick I'll pick a 8-core machine, or I'll pick a 16-core machine, and I'll do a VMDB system, right? And that's what I'm going for. Now the total node count is 1. If I had chosen 2 here, so there's an option of 1 and 2, it creates a rack for me, right? So I'll create one here. I'm going to create a standalone VMDB system. I could have created a rack here as well, right? If you're looking for any kind of HA, either go with rack or go with DataGuard, right? DataGuard, you can also do DR between different areas. So I would choose different the Oracle Software Edition here. Enterprise is fine, and then right here I have to select a storage size. I'll choose 4 terabyte. It's good for me for this demo. I have license included, or I can bring my own license. If I had my own license here, I could have chosen that option, right? In this case I don't, so I'm just do that. And then I have to give my SSH keys here. So I'll bring up my SSH keys on my local machine. Okay. And then right here, remember this service is running in OCI and it runs behind a virtual cloud network. So I have to choose a virtual cloud network. Now I have a bunch of these networks available. Let's say I'll use this particular network because this has an option, a subnet, which I can leverage. Now I can go with a public or a private. It's a good practice to go with private. Just for the demo purposes, I'm leveraging this this subnet, but good idea, good practice to always go with a private subnet. If you need to do things like backups, you can always do backups using the service gateway, right? I can choose host name, prefixes, etc. And then right here I have to give a database name. So I'll say this is my first DB, and I have to choose a database version. I'll go with 12.2, or let me actually 18.2, and then PDB name. If I wanted to do that, I could provide it here, and right here I have to give an admin password. And the admin password, you can see, has a very sort of a restrictive set of set of values I need to provide. So just make sure that you follow the requirements here. Let me just make sure that I'm following a password and it matches. And then I can configure automatic backups here, right? I could say, just do automated backups like we discussed, right? You could do manual backups, you could do automated backups, and I could choose the workload characteristic, whether this is OLTP or this is OLAP, right? I could do that, and I can do things like tagging, etc. If I wanted to do that, I could do tagging. So with those options, I can come down here and I can launch the DB system. Let me see why this is not coming up here. I need to put a host name prefix here, right? So I'll say this is my VMDB host. And right here I can launch the DB system, right? So I click on the launch DB system, and this would take anywhere from half an hour to 45 minutes to provision the DB system. And once the DB system is provisioned, I can see the various options which are available. So if I just click here, it's in the process of getting provisioned, and you can see this is my DB system. This is my physical, think about this as my physical host where I'm running the database, and right here is my database, first DB. And remember, this is a VMDB, so I can only have one database home, one database on this VMDB. If this was bare metal, I could have had multiple databases on these DB systems. Right here I can see things like patches. If right now it's in the state of getting provision, otherwise you can see some patches. If I applied those patches, I can see those patches here. So like I said, one database, one node, really straightforward. Once this takes around half an hour to 45 minutes. Once this is up and running, I can log into my DB system, and I can start creating tables, running queries, migrating data, etc. So that's pretty much everything on the VMDB system. And similarly, I could have spun up a bare metal DB system or an Exadata DB system and walk you through the features. The pricing is all available here on the website. You can look up the pricing for the bare metal, the VMDB, and the Exadata. Let me just summarize the OCI database service. So database service offers mission critical enterprise grade database service with comprehensive offerings, starting with our gold standard Exadata, real application clusters for HA, bare metal option for your mission critical databases, as well as VMs to cover your any kind of enterprise need you have. We offer complete lifecycle automation with provisioning, patching, backing it up, restoring the database. You can scale from one core VM to Exadata. We saw some massive numbers of cores available with Exadata, and we have various scalability and HA options, including DataGuard and real application cluster. We also saw that the service supports robust security controls, some of the controls coming from the OCI platform itself, and some coming from the database side. And then finally, for customers who have existing licenses, we support bring your own licensing model, so you can bring your own licenses and use them in the OCI database service. So with that, thank you very much for attending this course on OCI database service. I hope it was really useful.